Thank you, Mr. Kojak. Good morning, ladies and gentlemen. I'm Atsuto Kajiwara from Ministry of Land, Infrastructure, Transport, and Tourism, Japan. Thank you for inviting me and giving me such an opportunity this time. I'm in charge of the policy making of mitigation of greenhouse gas emitted from automobile, especially making fuel efficiency standards. Today, I'll talk about fuel efficiency regulation for heavy-duty vehicles in Japan, including the movement of the improvement. Before starting my presentation, honestly speaking, I'm not a good English speaker, so please forgive me in advance if you have troubles to hear or to understand my English. And, my presentation is divided into 4 parts. First, I will show you the background of heavy-duty vehicles fuel efficiency standards. And following that, we'll move on Japanese test procedure of measuring fuel efficiency of heavy-duty vehicles. And after that, I'll explain the target value and improvement, that is, effect of introducing the standard. Finally, I'll show you the overview of our integrated approach to tackle the global warming in the vehicle sector. So let's start. First, let me explain the background of Japanese CO2 emissions situation. This left chart shows the amount of CO2 emission from Japan, from all of Japan. The amount of CO2 emission from Japan is about 4% in the world. And as you can see, 20% of CO2 emission is coming from the transport sector in Japan. And 90% of that is coming from automobile, as you see in the right bar chart. So, policy for reducing CO2 emitted from automobile is a big key to tackle the global warming in Japan. Next, please. And this is amount of CO2 emission from each sector in Japan between 1990 to 2010. 2008, sorry. Total CO2 emission increased by 13.3% compared to 1990 level. But as you see, transport sector and the blue line has turned into decrease, while office sector, the green line, and the private sector, yellow line, has been increasing. This slide shows the trend of the amount of CO2 emitted from transport sector. Total amount of CO2 is reducing from 2001. And regarding passenger vehicle, yellow part, the amount of CO2 is reducing from 2001 too. And the amount of CO2 from commercial vehicle, blue part, is reducing. This peak was in 1996. And this is, we think, this successful situation is very rare case in the world. And this is a result of our policy, of course, with effort of automobile manufacturers and transport companies. To achieve such situation, several policies contributed, such as fiscal incentives or improvement of efficiency in the way of fleet transport and the promotion of eco-driving. I'll show you later that policies. And especially one of the most important policy we think is fuel efficiency regulation. Next, please. So this slide shows the history of our automobile fuel efficiency regulations. Originally, fuel efficiency standards for passenger vehicles started in 1970s. And the oil crisis happened in the Middle East area was the trigger of starting fuel efficiency standard. By this regulation, average fuel efficiency has been steadily improving. The latest standard for passenger vehicle is targeted for fiscal year 2015. And last month, we announced new passenger vehicle standard toward fiscal year 2020. This will be stipulated around next spring. And so we Japan introduced fuel efficiency regulation for heavy-duty vehicle in 2006 for the first time in the world, so which is today's main topic. Next, please. Next, I'd like to explain the drafting process of fuel efficiency standards. First, we establish an expert working group to start discussing a new regulation. And vehicle manufacturers provide fuel efficiency performance data with all the types of HDVs in the market, as well as their expectation on positive factors and negative factors. And positive factors such as available technologies and their estimated prevalence in the proposed target year. And the negative factor is regulatory impact of emission or safety regulations. We develop a draft proposal and submit it to the council body of the government. The council consists of academics and stakeholders. It intensively discussed the submitted draft proposal. The intermediate report of the council goes through public comment procedure, and the result must be taken into consideration when it publishes the final report. The final draft should be completed by MLIT and MLTI based on report by the council. The final regulation and test procedures are published after WTO TBT notification procedures. Okay. Besides, I'd like to show you our top-run approach. This slide shows how the top-run standard is set. A top-run approach is a fundamental concept to make the fuel efficiency standards. Target standard values have been determined based on the fuel efficiency of the most fuel-efficient vehicle, which was on sale at that time. In addition, the positive factors such as technology improvement of engines or transmissions, and negative factors that caused from exhaust emission regulations and so forth have been considered. The fuel efficiency strongly depends on vehicle weight, thus the target standard values are classified into some categories by gross vehicle weight. Okay, that's the end of the background of fuel efficiency standards. So let's move on our test procedures. Next, please. In Japan, fuel efficiency of heavy-duty vehicle is measured by engine dynamometer, not using whole vehicle. Fuel efficiency map of an engine is measured by this instrument, and fuel efficiency is calculated by computer simulation using fuel efficiency map and vehicle specifications. For fuel efficiency test, a mode called as heavy-duty vehicle mode is used in Japan. And this mode includes two modes. One is urban driving mode, and another is inter-urban driving mode. Urban driving mode is same as the JE05 mode, which is used for emission standard. And inter-urban driving mode is 80 km/h constant speed mode with road gradient. The below chart in the black profile in this the below chart profile indicates a road gradient history of the inter-urban driving mode. We combine these two driving modes at the fuel efficiency test. If you do the test by the actual engine bench test or an actual chassis dynamometer, the test is impractical because it takes large resources, time, labor, and money to construct the testing facility and to perform measurement for manufacturers. Therefore, we do the fuel efficiency evaluation test by simulation method. This is overview of the simulation method is shown here. This method includes two phases. One is a phase conversion from vehicle speed to engine speed and engine torque. This phase is used in the emission test by JE05 Mode 2. Another one is a phase of calculation of fuel efficiency. In the first phase, we convert driving mode to engine operating mode with engine speed and engine torque by the conversion program. In the process of this conversion, this detailed vehicle specifications are input to determine not only histories of engine speed and torque, but also gear shift positions. In the second phase, fuel efficiency is calculated from profiles of engine speed and engine torque. In this case, we need a fuel consumption map, which has fuel consumption values against the engine speed and engine torque. Before the simulation, we have to create this map by steady-state engine operating tests. And in the conversion process, we have to determine the gear shift position. To determine the shift position, much information and data are necessary. The vehicle specifications are divided into four categories: engine-related parameters, drivetrain-related parameters, and driving resistance parameters. And the last one is vehicle weight-related parameters. By using these parameters, we determine the gear shift position in driving modes and acquire engine speed and engine torque profiles. And here, let me explain about the meaning of the name of simulation method. This name is up to be misunderstood. The meaning is that the whole method is not an actual engine measurement test by driving mode. Of course, the simulation is based on real vehicle and engine specifications, and in using this method, we must obtain the fuel consumption map of the engine by steady-state engine bench test. This method is an extension of the emission test by JE05 mode, so that the fuel efficiency test has low cost and good test efficiency. At the same time, the method has problems of reproducibility of driving resistance value of the actual vehicle, because the test includes a conversion process from vehicle speed to engine speed and torque. And this slide shows a flowchart of simulation method. Fuel efficiency values of urban driving mode and interurban driving mode are calculated by the simulation. And finally, we combine these two fuel efficiency values. To combine fuel efficiency values, we use this equation and prepare two coefficients AU and AH. These two coefficients indicate the driving distance proportions of urban driving mode and interurban driving mode. Driving distance proportions AU and AU have been determined according to 7 kinds of vehicles. Passenger vehicles are categorized into 3: ordinary bus with GVW of 40 tons or less and over 14 tons, and route bus. And fleet vehicles are categorized into other than tractor with GVW of 20 tons or less and over 20 tons, and tractor with GVW of 20 tons or less and over 20 tons. Total fuel efficiency of heavy vehicle mode is calculated from the fuel efficiency of urban driving mode, that of interurban driving mode, and the proportion shown in this table. Okay, that's the end of the test procedures. Next, I want to show the target values improvement. This slide and the next slide shows the target standard values for heavy-duty vehicles in each category. First slide shows the values for route bus and the ordinary buses. And next, please. And the second slide shows the values for truck and tractors. And I'd like to show you the effect of the standards. This graph shows the improvement of average fuel efficiency in each category. And T means truck, and the TT means tractor, and the BR means route bus, and the B means ordinary buses. And as you can see, average fuel efficiency has been increasing to the target values. However, in some categories, especially in buses, average fuel efficiency has not been improved well. We haven't had a detailed analysis and discussion for this, but in my opinion, this is because there are a few types of buses in Japan. The number of types of buses is fewer than that of trucks, and the manufacturer hadn't introduced new models yet. So, because as they care the timing of the reinforcement of emission standards. The second graph showed the average improvement of heavy-duty vehicles between 2002 and 2015. As for the average, fuel efficiency is steadily improving from 2002 and to the fiscal year 2015 target. Therefore, we think that the two sets of fuel efficiency target value is effective to encourage auto manufacturers to develop new technology and improve fuel efficiency. Finally, I'd like to explain our integrated approach. The key for success is an approach to integrate all the relevant measures in coordinated way. We have a variety of elements which affect performance of transport sector, not only vehicle technology, but driving behavior, traffic flow, and efficient logistics and mobility management. We need evolutions for all the elements for the better future of transport, and all the measures must be incorporated in a coordinated manner. Considering the measures for reducing CO2 emissions from motor vehicles, reduction of emission from the vehicle alone is almost always argued first. In particular, improvement of fuel efficiency is argued. We of course do not deny this, and there is no doubt that it's an important element. However, we believe that it's not the best approach to implement measures focusing only on the improvement of motor vehicles alone. Thus, the concept of integrated approach was introduced in Japan. And first, I'd like to explain incentive measures for promotion of purchasing fuel-efficient vehicles. Japan has tax incentives to vehicles which meet high fuel efficiency level. Such incentives include reduction of the tax burden on the acquisition and possession of these vehicles. We call this the green taxation system. Japan has been promoting popularization of fuel-efficient vehicles, not only by regulations, but also by incentives utilizing this kind of taxation system and labeling or sticker scheme. We provide subsidies to automobile carriers when they change old vehicles to eco-friendly vehicles, such as electric vehicles, plug-in hybrid vehicles, and CNG truck and buses. And also, I'd like to explain the promotion of eco-driving as an example of usage improvement. Eco-driving is one of the most effective measures. It significantly contributed to fuel efficiency and CO2 reduction by 10% on average in Japan. Campaigns and educational programs should be important element as well as in-car equipment to assist eco-driving. And we have been implementing next generation EFV project to encourage the manufacturers to develop next generation heavy-duty vehicles since fiscal year 2002. Until now, we developed 7 types of next generation heavy-duty vehicles, and demonstration experiments were conducted by automobile carriers. Now we are developing plug-in hybrid trucks and high-efficiency hybrid trucks, next-generation biodiesel engines, and high-performance electric bus in industrial and government and academic research groups. And we have to make the best use of EFVs according to the technological specifications of each type of vehicles. The main field for electric vehicles and plug-in hybrid could be limited to urban area due to the limitation of energy intensity and driving range per charging, though it has an average in environmental performance there. It also means we will have to be dependent on ICE technologies even for the future, considering required driving range or loading capacity. In this sense, improvement of ICE technologies, especially for HDVs, must be focused and pushed more for the sustainable future of transport. And I have given several examples so far, but these approaches are not independent of each other. In an integrated approach, it is important to make these approaches interactive in order to provide the most efficient measure. This is a concept towards the future transport. We, the government and automobile industry, should seek for harmonized and coordinated evolution of all the elements towards zero-emission technology, based model mix and compact cities. And that concludes my presentation. Fuel efficiency target standard values for heavy-duty vehicles were set in Japan in 2006 for the first time in the world. And average fuel efficiency has been improving from 2006 by introducing the target standard values. In the test procedure, Japan has been using the simulation method because the standalone engine test requires large resources. And Japan has been taking integrated approach to mitigate the global warming, not only the improvement of the vehicles, but also the usage of them and the city planning. Thank you for your attention.
Thank you very much.